On our third day of programming here, we're just going to take a closer look at some of the options you have for different variable types. There are quite a few, but today we're just going to expand our numbers of types to 4. One of them is the character, which is great for storing individual letters only, like the letter W, but only one letter. A string is great for storing a whole bunch of letters. It could be a word or it could be a sentence. It could be the word wonderful. And then 2 that you already know. Integers are for whole numbers. It's okay if they're negative, but they have to be whole numbers. And floats are great for numbers where there's definitely going to be, or there could be, a decimal part to them. So if you know your number is going to have a decimal part, you want to declare that as a float. And speaking of declaring variables, here's what it would look like to declare those 4 different types of variables in C and C++. For the most part, it's the same, except for when we're trying to declare the string. So if it's a character, you would just use char. If it's going to be a string, then in C++, you can just actually use the word string. But in C, you have to tell it that it's a whole bunch of characters, and that 50 at the end gives you an upper limit on how big that actual string could be. So you will have to warn the compiler on an upper limit on how big the string would be. For integers and floats, they're both the same, C and C++, just int and float. But again, just pointing out that C doesn't handle strings very well, so you will have to give it advance notice, give the compiler advance notice on how big this string might be. It's okay if it's smaller, but you do have to provide an upper limit. When it's time to actually store values, if you're storing a character, you can just use the equal sign to do an assignment, and the character goes in single quotes. If you're trying to store a string, C++ is fine. You just use some double quotes in order to store it. But for C, you actually have to use this command, string copy, or strcpy, and then that line there would actually store the string Bob into first name. And it's okay if first name has been declared to be 50 characters long. That's fine. It'll put the Bob in there, and then a little marker in there saying, oh yeah, 3 letters, and then we're at the actual end of the string. For declaring, or I should say, for assigning integers and floats, for C and C++, it looks the same. You can just use the equal sign in order to make those assignments. Just pointing out again, it is a little bit awkward in C handling strings. It doesn't like to use strings very much, and you have to use this string copy in order to actually store a value into a string variable. If you want to have the user enter values in real time while the program is running, then in C++ it just uses the cin, which is great, and then the double arrows to let the compiler know where that information is going to get stored. And that's the same for characters, strings, integers, and floats. But for C, we're going to use scanf, and you will have to give it notice of what to expect, and that's after the % sign. So the %C says, all right, you should expect a character to be typed in. And the next line down there does have a % and then quite a mess, but then there's an S letting us know that it's going to be a string that will get stored, or %I for an integer, or %F for a float. The crazy stuff in the square brackets for the input of the string just lets the compiler know that, yeah, we're going to be typing in some characters, but then once we get to an enter, that's when you can actually say that the string is finished. Do notice these 2 spaces that are there for the characters and for the strings. Those are actually important. Make sure in your blue quotes you've got a space in there in order to get the compiler to digest that correctly. When it's time to print values out to the screen, if it's C++, you can simply use cout, which is great. And then the double arrows say, yes, we're going to be sending those memory values out to the monitor. If you're using C, it's got to be printf, and we use some placeholders to let it know that we're going to be printing either characters, which is the C, strings would be S, integers would be I, and then floats would be the F. That just lets the compiler know what to expect, and then after the comma, you've got the various memory locations, and it will go and grab those values and then print them out on the screen. Just a little comment on using printf in C. You can print whatever additional text you want in the blue quoted area. So if you look at the example down below, it's going to print off the mass of cat, and then it's time to print out the cat's name. So there's that %S. It's a little placeholder for a cat name. And then the word is will get printed, and then another little placeholder for a float, and then finally kilograms and the period. And so the compiler will go through when it runs now and say, oh, I need to print a string, and then it will go and find that output list and go, oh, first name should be printed right here. And then it keeps printing the word is, and then it goes, oh, I need to print out a float. Who is it? And then it looks at that output list and goes, oh, it's the mass. And then it will actually go and print the mass value right there. So you can have multiple lines or multiple variables printed out on one printf command. That is absolutely acceptable. Finally here, just a few little tips with how you can be doing some math and just handling various variables inside your program. First of all, just a couple of things that can go wrong on you, just some mismatching errors. I've got some code here that might be in your program. Maybe this is C++, and you've declared a string. It's going to be somebody's name, and then an integer for their age, and then float for mass. And these two commands here may or may not cause you problems. Well, the cin command may cause you problems, but the last line will cause you problems for sure. In that cin command, that's where we're asking the user to type in an age, and if they were to type in something other than an integer there, like if they were to type in their name, that would definitely cause an error that would happen during the time that your program is running. The last line is going to try to take whatever is their first name, some sort of string, and store it into this memory location called mass, which is reserved for floats, and that is not going to go well. And so usually the compiler will catch that while you're compiling it and say, nope, something's wrong here, these things are mismatched. You can only store strings in strings. We can't store a string name into a float variable very well. Next issue, just typecasting. I've got a couple of lines of code here, and maybe this is some physics. We're trying to figure out some distance using a physics formula, 1/2 at squared. So I've kind of declared my variables, distance, acceleration, and time, and even actually put in some initial values for the acceleration and the time. And then these three various lines here are going to do different things. In the first line for distance equals, the 1 in that 1/2, that 1 is an integer, and that sets the calculation off as being an integer only. And so when it first wanders through from left to right, 1 divided by 2 is actually going to be 0.5, but as an integer it's going to round down and it's going to evaluate that as 0. And that actually gives you 0 for the entire result, which is definitely not what you want. And that's true even though distance has been declared as being a float. It doesn't matter. That very first pink 1 is going to say, oh, we're working with integers here, and it's going to corrupt your calculation. The second line works better. That 1.0 starts off the calculation over on the right-hand side of the equal sign as being a float. And even though you divide by an integer, that's okay. You can divide by that too. But that very first 1.0 says, no, 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 this is going to be a float. And then the result is, as you would expect, 26.8304. And the last method also works very well. That actually officially declares this type. It kind of casts it as being a float. So when you have that pink 1 there, it's okay. The compiler knows that no, 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 this is a float calculation, and it will give you the correct result of 26.8304. So just be very careful of that first distance line with just a simple 1 divided by 2. That's the kind of thing that you might want to avoid in your calculations. A little note up there about the actual time multiplied by time. You might think that you could go time to the 2 is equal to time times time, like time squared. But actually time to the 2 is not what you would expect in C. So you'll have to actually use time multiplied by time, or there is actually a power command that we'll take a look at a little bit later. But time with a little caret and then the 2 doesn't actually work. Rounding numbers, some options here. I've got some code, got a couple of variables. One of them might be that distance that has quite a few decimals to it, and then we might want to try to round that and then store that rounded answer. And we've got 3 different options here. The very first line just says round distance. That will round the distance, which is a float. It will round it to the nearest whole number, doing the usual rounding that you would expect. And if you want to have just a whole number, that's fine. The second line will actually take the distance. It'll multiply it by 10 first, and then round. So now it's actually rounding down in what would be the tenths of the original value for distance. And then you divide by 10 when you're finished to put the decimal back to where it should be. So all in all, that second line will round distance to the nearest tenth. And likewise, the third line will actually round your distance to the nearest hundredth. And that way you can display it as you wish. If you only want to just print some numbers that are rounded, and you don't really want to actually round the values, there are some options, but that would be using the printf command. So I've got this line of code here, or a few lines of code. There's a declaration. We're going to declare this variable distance as a float, and then instantly store some value in it. And you can see it's fairly long, and it's got quite a few decimals to it. And then 4 different options here. And the compiler won't actually color those 9.2s and 0.2s and 7.0s as orange, but I've just put them in to kind of highlight them. I put them in as orange to highlight them here for you. The first line will actually go through and type out your answer is, and then the percent and the F says, hey, expect to see a float, and it's going to be the value for distance. But the 9.2 between the percent and the F says use at least 9 spaces, more if you need, but at least 9 spaces to do it, and round the answer to 2 decimal places. And so you can see in green what it would actually show. It would say your answer is, now 9 spaces means it's going to pad the beginning with a few extra spaces there, and it'll display the value rounded to 2 decimal places, so it'll have a 6.8, and then the word meters. The second line says, I'm not too worried about how many spaces to use overall, but make sure you round it to 2 decimal places. So that'll look a little tighter. It won't have the extra zeros, or the extra spaces, I should say, padded on the front end. The third line would say, well, use at least 7 spaces, more if you need, but at least 7 spaces, but then no decimal places. So round it to the nearest whole value. And the value would get displayed as just a simple 1, 2, 3, 4, 6. It would round that 5 up to a 6 when it displays it. And the fourth line will say, hey, I'm going to use at least 3 spaces, and it also rounds to no decimal places if you don't put anything after the decimal point. So you've got a couple of options there for how to round float values to the nearest whole number. Last little thing, this can be useful for some programs down the road when we try to test for prime numbers. It's called modulo arithmetic. It's all about doing remainders or figuring out remainders when you divide one number by another. And so here are a few lines of code. I've declared this number, big number, and then instantly assigned it a value of 123, and also declared another value there called remainder. In this case, I actually probably should have used integers instead of floats there, but that's all right. It's the percent calculation that I really want to highlight here at this point. The first line is going to calculate the remainder when 123 is divided by 4. It doesn't really care about the actual quotient, like what answer you get, but it's focused on the remainder. So if you take 123 and divide by 4, it doesn't divide evenly, and you end up with a remainder of 3. And the value for remainder then would be simply the number 3. The second line will take that 123 and it will try to divide it by 7. And it doesn't go evenly, but it'll tell you that, oh, the remainder is actually 4. What might be more interesting is the last line, and this is how you may end up actually using this. If you take that big number 123 and divide by 3, it actually goes perfectly, and so the remainder is 0. And this can be a way to test to see if numbers are prime. You can go through and see whether or not various other smaller numbers divide into it. So if you notice that when you use that modular division, that percent symbol, that when you divide by a number, like say 3, that the remainder is 0, then you know, oh, okay, that's actually a multiple of 3.